speaking of things a billion miles away, NASA scientists have achieved a rather remarkable feat. They have been able to revive Voyager 1.
Suddenly, Voyager 1 started sending back pure nonsense, and NASA is racing against time. Last December, it began spewing out bizarre binary codes, just ones and zeros that baffled everyone. NASA's best minds tried over and over to reset the system, but nothing worked. What if these scrambled signals are a warning? Join us. Let's urgently uncover what's really happening out there. The silent crisis, Voyager 1's troubling data. The beloved space explorers, the Voyagers, have captured our attention again. Recently, there was a tense moment when we almost lost contact with Voyager 1. On December 12, 2023, NASA reported a serious problem with Voyager 1's flight data system, which includes 3 onboard computers. These systems started sending back confusing binary data to Earth, a series of ones and zeros that made no sense to the engineers. When the problem first appeared, NASA's engineers could still send commands to the distant spacecraft and confirm that its systems were working. But the data it sent back was gibberish, showing a major issue. NASA's first move was to try a system reboot, hoping to fix the error, but this didn't work, and the spacecraft kept sending the same confusing data. For months, NASA engineers tried everything they could think of to fix the issue. They kept trying different solutions, working hard through trial and error. Finally, they came up with a promising fix. More on that soon. Before we get into their clever solution, it's important to understand what was at stake with Voyager 1. When scientists looked closely at Jupiter's moon, Io, they discovered it wasn't just a quiet rock in space. Instead, it was a world bursting with volcanic activity. A special image showing a volcano on Io throwing material into space was so amazing that it surprised everyone, from casual stargazers to experienced NASA scientists. This picture was important because it changed how we understand the solar system. In a similar way, Voyager 1 captured a stunning image of Saturn that wowed people around the world. The rings of Saturn, always beautiful, were shown in more detail than ever before. But the probe also brought exciting news about Titan, Saturn's largest moon. It suggested that there might be liquid water on Titan's surface, sparking hopes about the possibility of life, or at least conditions where life could exist far from Earth. These findings by Voyager 1 were just a few highlights of its journey. But what happened to Voyager 1, and why did its communication with Earth become sporadic? It turned out that the spacecraft had a major problem. The flight data system, crucial for its operations, broke down. This system is vital for Voyager 1 as it travels through the unknown vastness of deep space, needing to function on its own. Voyager 1's flight data system is a complex set of parts that keeps the spacecraft running smoothly. This system includes everything from the main computer and data storage units to the command interface and telemetry systems. A glitch in Voyager 1's system challenges NASA's engineers to find a fix. Voyager's central nervous system. The glitch we're talking about came from a problem within this flight data system, which is a key part of the spacecraft's design. This system manages and processes all the data Voyager 1 collects during its mission. You can think of it as the spacecraft's central nervous system, organizing the activities of different subsystems and making sure everything keeps working during its long journey. After months of trying to figure it out, experts are getting closer to understanding the glitch's cause. This deep dive into the problem not only shows how hard it is to manage such old technology in space, but also highlights the incredible creativity and planning of the engineers who designed Voyager over 40 years ago. This exploration into the glitch and how we communicate with Voyager 1 gives us a fascinating look at both the limits and amazing successes of early space technology, which continues to send valuable data across huge distances. At NASA, engineers faced a big problem when they found that about 3% of the flight data system's memory on one of their probes was corrupted. This was probably due to charged particles in deep space, although it could also be because the hardware was getting old. Since they couldn't fix the faulty memory chip from Earth, the team came up with a smart solution. They broke up the damaged code and moved the pieces to unused parts of the system's memory. The first update to fix the problem was sent to the Voyager 1 probe on April 18th. Then they had to wait nervously because the signals had to travel a huge distance of 30 billion miles round trip between Earth and the spacecraft. Finally, on April 20th, 2024, NASA's control room was relieved when they got confirmation that the update worked. The next step was to rebuild the lost parts of the code, which was very important to get the probe to send back valuable scientific data to Earth. Over the years, the Voyager probes have had many system failures due to the harsh space environment. After losing contact with Voyager 2 in August 2023, engineers thought it might be lost forever. But just days later, the connection was miraculously re-established. Since the mission has lasted so long, NASA had to turn off several systems on the probes to save power. Right now, Voyager 1 uses only 4 of its 10 original instruments, while Voyager 2 keeps 5 active. Voyager 1's failing systems push NASA to get creative. The silent guardians of the cosmic frontier. To keep the remaining systems, including the high-gain antenna, which is essential for communicating with Earth, running longer, NASA turned off heaters and other non-essential components. The probes still carry vital instruments like the magnetometers, which are crucial for studying the magnetic fields of the Sun and outer planets. In 2015, these instruments made an important discovery that solar winds could affect magnetic fields even beyond the heliopause, the boundary where the Sun's influence ends. Both Voyagers still use low-energy charged particle detectors, which helped find the heliopause after a big solar event in 1993. The hydrazine thrusters on the spacecraft are also still working, helping to move them through space and maintain their temperature. The probes have micrometeorite shields to protect their rear instruments from space dust and debris. However, the challenge didn't end there. Another important system still in use is the optical calibration target instruments. These ensure the accuracy of each probe's sensors by regularly aligning them with a target plate. This calibration has been done many times during their long journeys, keeping their scientific measurements accurate. Even though other instruments have been turned off, some for decades, these measures help Voyager 1 and 2 continue to teach us about space. To manage their energy, the probes use radioisotope thermoelectric generators. These important devices use the heat from decaying plutonium-238 to power the spacecraft and keep them warm. This clever technology has helped the missions last much longer than expected. However, the power from these generators is slowly running out. Eventually, they will stop working entirely, ending the probe's long journeys through space. This might happen sooner than we think. Even when the probes go silent, their contributions to science and our understanding of space will still matter. Each spacecraft carries something very special, the Voyager Golden Records. These records are attached to the sides of both Voyager spacecraft and were made as time capsules to tell the story of our world to any advanced alien civilizations that might find them. The records have sounds and images that show the diversity of life and culture on Earth. They include human society, natural sounds from our planet, and greetings in 55 different languages. If an alien civilization ever finds these probes, the records could be their first introduction to Earth's rich heritage and complex biosphere. This makes the Voyagers priceless, not just for what they teach us about space, but for the possible connections they could create with intelligent life forms in the universe. Voyager's journey through space reveals new cosmic wonders. Messages carried by Voyager. Even as the probes travel silently through space, they continue to symbolize human curiosity and our desire to explore the unknown. The Voyagers remind us that our quest to understand the universe never truly ends. The records also contain 116 images encoded in analog form that show various aspects of life on Earth. These pictures give a visual introduction to our world, portraying the everyday lives of people and the unique features of our planet. The goal of these images and sounds is to give a snapshot of Earth, a friendly handshake extended into space, inviting anyone who finds the record to learn a bit about the planet it came from. This ambitious project reflects our desire to connect and communicate across the vastness of space. It shows our hope that somewhere, out there, someone might hear these echoes of Earth and feel a connection to a distant blue planet orbiting an ordinary star. But this wasn't the only goal. The Golden Records stand as a testament to the human spirit's unyielding desire to reach out, explore, and share the essence of our world. But this wasn't the only amazing part. The records also include sounds of Earth, like the wind, thunder, and even human heartbeats. This way, anyone who finds them gets a real sense of what life is like on our planet. What's more, the records feature music from different cultures and times. From classical music to traditional songs from around the world, these sounds show the richness of human culture and creativity. And so these golden records travel through space, carrying a piece of our world. They might be our lasting message, floating in the cosmos, waiting to be discovered by someone out there. These records weren't like regular vinyl discs. They were made of durable copper and coated with gold. They were designed to survive the harsh conditions of space and could potentially last billions of years. The records had instructions on them, not just in English, but using mathematics and physics, so any intelligent life form could understand. The instructions explained how to make a stylus and a cartridge to play the records. This careful planning ensured that if intelligent beings found them, they could still understand the message. The golden records on Voyager reach out to unknown worlds, Earth's location in the cosmos. The records also included a diagram showing the location of our sun compared to 14 pulsars. Pulsars are special stars that emit beams of radiation and can serve as universal landmarks. Using these pulsars as reference points, the diagram mapped out Earth's location in the Milky Way. This was a brilliant idea, but also a bit risky. On one hand, it was a way to reach out to other civilizations. On the other hand, it raised a concern. What if these directions led the wrong beings to us? But this wasn't the worst part. Imagine if somewhere in the vast universe, there are beings with not-so-friendly intentions. By giving them a map to Earth, we might accidentally invite trouble. Yet the main goal of the golden records was to offer a friendly hand across the stars. They were filled with sounds and images showing the diversity of life and culture on Earth. It was a message of goodwill from humanity. It was a bold statement saying that, in the vastness of space, Earthlings are here, ready to share, learn, and maybe even warn others about the fragility and beauty of our world. Voyager 1, currently about 15 billion miles from Earth, faced a communication issue when one of its onboard computers, the Flight Data Subsystem, started sending garbled data. Engineers managed to detect a different pattern in this data, which turned out to be a full memory readout from the subsystem. This discovery provided crucial clues for addressing the communication issues, although fixing them is complex due to the immense distance. Signals take approximately 22.5 hours to travel one way. Meanwhile, Voyager 2, which is a bit closer at around 12 billion miles away, continues to operate with all systems nominal. It too faced potential power issues due to voltage fluctuations that could endanger its instruments. Engineers devised a strategy to use a small reserve of power from the spacecraft's radioisotope thermoelectric generator, thus ensuring the continued operation of its scientific instruments. However, the story doesn't end there. Keeping this connection requires careful calculations and adjustments from mission control. It's like a delicate dance between space mechanics and human effort. This highlights our never-ending desire to explore and understand the universe. At a speed of 67,000 miles per hour, Earth in its orbit catches up to both Voyager spacecraft. Even with the huge distances involved, this incredible speed means that, for a short time, Earth actually gets closer to these distant explorers. It's not the Voyagers changing their path. It's Earth, with its big orbital route, that makes this temporary closeness possible. Their ongoing mission provides not just scientific data, but also continuous inspiration, showing what we can achieve when curiosity meets advanced technology. Each signal we get from these distant messengers brings new insights and reminds us of our small place in the huge cosmic space. The success and longevity of the Voyager missions have driven significant technological advancements. Modern spacecraft now feature autonomous systems capable of making decisions without real-time input from Earth, crucial for missions venturing far from our planet. New communication technologies are also being developed to maintain contact over vast distances, ensuring future missions can relay data back efficiently. NASA and its international partners have ambitious plans. The Artemis program aims to return humans to the Moon and establish a sustainable presence as a step toward Mars missions. The Mars Sample Return Mission, a collaboration between NASA and ESA, seeks to collect and return Martian soil and rock samples, potentially revealing if life ever existed on Mars. The challenges faced by the Voyager missions, like dealing with old hardware and harsh space environments, have taught valuable lessons. These experiences have led to better data management and error correction protocols, helping future missions handle unforeseen issues. The creativity and problem-solving demonstrated by Voyager engineers continue to inspire new generations of space scientists and engineers. One of the most exciting prospects is the search for extraterrestrial life. Missions targeting Jupiter's and Saturn's icy moons, like Europa and Enceladus, aim to explore their subsurface oceans for signs of life. Discovering liquid water and potential habitable environments in these distant worlds could change our understanding of life's possibilities beyond Earth. Balancing space exploration with addressing Earth's challenges remains critical. While the pursuit of knowledge and groundbreaking discoveries drive space missions, ethical considerations, such as the risk of contaminating other worlds and resource allocation, are important. The possibility of encountering extraterrestrial life raises philosophical questions about our place in the universe and our responsibilities as explorers. Public interest and funding are vital for sustaining space missions. Educational programs and initiatives that inspire the next generation of scientists and engineers are crucial. Engaging storytelling through media, public outreach, and collaborative projects can keep the public informed and excited about space exploration, ensuring continued support for future missions. Do you think humanity should prioritize exploring space over solving problems on Earth? Share your thoughts in the comments, and don't forget to leave a comment, and subscribe for more.